Hello, Safa. I wanted to make you a video for this assignment to explain to you what you were supposed to do for this assignment. I'm not sure that you had a good understanding of what they were asking you to do. The instructions in the assignment and the title for the lesson are to find asymptotes. And so we are looking for the vertical asymptote and the horizontal asymptote of all of these functions. I'm not sure what you're finding here. It looks like you have a start at finding your vertical asymptote. I don't know why you're using L'Hopital's rule. We didn't learn that in this course. It's not part of our curriculum, so it's not something that you should be using to answer any of the assignment questions. I also don't understand why you're finding intercepts, because you were only asked to find asymptotes. So I'm going to just go through one of these examples with you very briefly and just explain what you should have done so that you have a better understanding. And hopefully that will help you when you do the Unit 4, sorry, not the Unit 4, but the midterm test, midterm exam, when you've completed Unit 4. So the first thing we want to do is find our vertical asymptotes, and you have made a start at that here. I can see that that's what you're trying to find. We recognize that when x equals 1, we would have a vertical asymptote or a discontinuity in this graph. And this numerator, the polynomial function, does not factor. So we cannot remove the discontinuity. We can't take the x minus 1 out as a factor in the top and cross it out with the bottom. And so we have a boundary line at the vertical asymptote when we're drawing our graph. At x equals 1, we'll have a dotted boundary line that the graph cannot cross. Now, what we want to do there is find out how the curve is behaving as it gets close to that line, because that tells us a lot about the shape of the curve that we want to draw later on for this polynomial function, for this rational function. So what we do is we find the limit as x approaches 1 from the right, and we find the limit as x approaches 1 from the left. So in other words, we want to know, as we're coming towards the asymptote from this direction, what's the curve doing? As we're coming towards it from this direction, what's the curve doing? So we will be able to have a good idea on both sides of that line what the curve looks like on the graph. So what we're going to do is choose a value. If we're coming at it from the right, if we're finding the right limit, we're going to choose a value that we would pass through just before we get to 1, so a value like 2. If I fill in 2 into the equation that I'm given into this function, then I'm going to have 2 times 2 squared, which is 2 times 4, which is 8, minus 5 times 2, so minus 10, so now we have minus 2, and then plus 3 equals negative 1 on the top. And on the bottom, if I put a 2 in here for x, I'll have 2 minus 1 is 1, and so I end up with a negative answer. Now what that tells me is that this curve is approaching negative infinity as it's coming at the asymptote from the direction of the right. So I've drawn on the graph what this curve is going to look like. It's going to be coming down like that as it gets closer and closer to the asymptote. If we do the same thing for minus 1, we will get, if we go through minus 2 as our number before we get to 1, I'm sorry, not for minus 1, for 1 from the left. So we would go through, let's say, 0 just before we got there on the left side. Then we would have 0 minus 0 plus 3, so positive 3 on the top. And on the bottom, 0 minus 1 is minus 1. We end up with negative 3, so that's negative infinity as we approach the asymptote from the left. So also going down like that, okay? So The other part that's missing from your work is to try to find the horizontal or the slant asymptote. So I'm going to write that down at the bottom here where there's a little bit more room. The horizontal asymptote, we find this by looking at the degree of the terms in your equation. Now, what's happened here is we have a higher degree in the numerator than any of the terms in the denominator. And so instead of a horizontal asymptote, we will have an oblique asymptote. An oblique asymptote requires you to use either long division or synthetic division to find the value of the asymptote. So in this case, if I divide x minus 1 into 2x squared minus 5x plus 3, I'm going to have 2x to start with, and I'll get 2x minus 2x. When I subtract those, I'm going to get minus 5x plus 3, and then I'm going to have to put a minus 5 to make that match. So my oblique asymptote is y equals 2x minus 5. It's an equation of a line. It's just going to be a slanted line instead of a horizontal or a vertical line. Now we also have to check our oblique and our horizontal asymptotes, and we do that a little bit differently than we do with the vertical asymptote. So let me show you how to do that. So what we do here is we find the limit for very large and very small values of x, and by very large, x equals 10 will do for that. So we find the limit as x approaches 10 of our function subtract the equation of the asymptote. Now, if this turns out to be positive, that will tell us that the curve lies above the asymptote. If it turns out to be negative, it tells us that the curve lies below the asymptote. So if we substitute 10 into our equation, then we get 200 minus 50, so we have 150, plus 3 is 153 over 9 minus 15. And so this is going to be positive when we work it out, and that tells us that the curve is above the horizontal asymptote, or the slant asymptote in this case, okay? So you would do the same thing. I don't think I need to write it out here, and the video is getting a little long. We would do the same thing for minus 10. We would substitute that into the very same equation. If it turns out positive, it tells you that we're above the slant asymptote. If it turns out negative, it tells you that we're below the slant asymptote. And that information is very, very valuable when it comes to writing the graph, to sketching the graph, because now we have a really good idea of the shape of the graph, okay? So if you have more questions about this, please go back and look at the lesson for asymptotes in Unit 3. There is a video there that's very similar to this, showing you another example of how to do it, and a couple of written examples as well. And I think that will help explain what you need to do here for this assignment. If you'd like to try it again and resubmit, I'll be happy to remark it. Thank you.